This is a demonstration that demonstrates the difference between an indefinite integral or an antiderivative and a definite integral. Now this is a graphical demonstration on the differences between these two ideas. And what we have here is we have a point t, we have an a value equal to 1.64, and we have the basic curve of x squared operating as our function for this demonstration. Now the a value is going to correspond to the area from x equals 0 all the way out to the x-coordinate of this point t. The y-coordinate of the point t corresponds to the actual area being determined. And what happens is the following. If I were to evaluate the definite integral of x squared from 0 to 1.7, I would get an area that's approximately equal to 1.64. If I change this value to 2.4, I get 4.61 for the area. And this again is the integral from 0 to this x-coordinate of 2.4. Now, these points that are being traced out here are all evaluations of definite integrals from 0 to whatever this n value is. And if I go through and generate a whole sequence of these points, I get the trace out of a very specific curve. And it is this curve that corresponds to the indefinite integral without the constant of integration, or you may assume the constant of integration to be 0. So a definite integral for this demonstration would be the area from 0 to a specific x value, and that would correspond to one single point along this curve. The collection of all of these points would correspond to a member of the family for the indefinite integral. And that is one way to tell the difference between a definite integral and an indefinite integral using graphs.